Before you get started on this week's lab, you want to make sure your lab notebook is ready to go. Check with your instructor on the details that they want, but you most certainly will need the title of your experiment, your name, and the date. You may want to write down the formulas that you will be using or notes about the particular experiment that you're going to be doing. Your instructor may ask you to write out detailed instructions. You also want to set up tables so that you're ready to start recording any entries that you need. Measure the temperature of the water you will be using because, like most substances, water's density will change with temperature. You will want to make sure that you have the thermometer sitting in the water for at least 30 seconds, just in case the temperature of the room and the temperature of the water are slightly different. When you first use the top loading balance, you may notice that the number is slightly off from zero. If it is, you're going to zero the balance, which is sometimes called tare. On this balance, it just says zero. On some balances, you will see TARE. You're going to place your dry graduated cylinder on the balance and record the mass. Remember that your lab notebook should contain all of your original measurements. This is your rough draft. You shouldn't copy over into your lab notebook from anywhere else. Also, make sure that you record units when you are recording any measurement. Remember that you want to measure between 12 and 15 milliliters in order to have enough significant figures. Always do your measurements with your eye at the same level as the meniscus. One way that you can tell that you have your eye at the same level is that if you look at the lines that go all the way around the graduated cylinder, they should match up pretty well at the level that your eye is. Right now, this graduated cylinder has my eye at about the 23 milliliter mark. So I need to move my eye down a little bit so it's closer to the appropriate measurement. I'm going to read the bottom of the meniscus. I'm going to record every digit that I know for certain and estimate the last digit. Then place your graduated cylinder back on the balance. Make sure it is the same balance so that any variation that is due to the way that particular balance is calibrated is accounted for. Record the mass in your laboratory notebook. Empty your graduated cylinder into the sink and repeat the experiment 2 more times. Think about, does your graduated cylinder need to be dry, and how dry does it need to be? Is this device meant to contain, or is this to deliver a certain amount of water? What would happen if it were wet, and how would that impact your results? After you have checked your burette for any chips or cracks, and to ensure that it is clean, you will need to fill your burette so that the meniscus sits somewhere between the 0 and 5 milliliter mark. Don't try to hit the 0 mark exactly. Then you're going to need to prime the burette. This is because while you were filling it, the valve and the bottom of the burette still have air in them. So to prime them, put a small waste beaker underneath and open the valve. Let the water run long enough so that no air bubbles are in the tip of the burette. Then remove this and set it aside so you don't confuse it with the other beaker you will be using. Record the mass of your 150 milliliter beaker on an analytical balance. Notice the difference between the analytical balance and the top loading balance. You're going to have more significant digits, and there are doors all around it. The doors help to control the air and keep the air from changing the recorded mass. So make sure that the doors are closed before you do your reading. Just like with the graduated cylinder, you're going to need to make sure that you are at eye level. Depending on your height, you may need to adjust the burette by lifting it up or by lowering it down, or perhaps even standing on a stool in order to make sure that the height is correct for your measurements. Again, try to align the lines that wrap all the way around the burette so that they overlap with one another in your line scheme. You can see that around the 5 and the 6 this is happening, but around the 10, 11, and 12 this is not. Record your volume to 2 decimal places, then add between 12 and 15 milliliters of water. You don't need to watch what's going into the beaker. Instead, pay attention to where the volume is going so that you can turn off the volume as it gets close to the mark. Again, make sure your eyes are at the appropriate level and record your reading to 2 decimal places. If you need to, it may be helpful to have a white or a dark card behind the burette. Don't empty that beaker. Take it over to the analytic balance and make another measurement, this time with the water still in it. Make sure your doors are closed and that the numbers on the scale have stopped moving. The analytic scale will continue to measure even small drops of water as they are in the beaker. So rather than trying to make sure it's scrupulously dry, we're just going to add each of our measurements on top of this. So make sure when you're doing your calculations, you use the final measurements of volume and mass from one trial as the initial measurements of volume and mass for the next trial. In general, when you're done with a burette, clean it, turn it upside down, and leave the stopcock open so that it can drain and dry for the next class.